Bismillahirrahmanirrahim. Welcome to the online lecture series on power electronics. Today we are going to discuss semiconverters, and this topic is related to the controlled rectifiers, which we have discussed in our lecture number 15. So we will start our today's lecture, which is single phase semiconverter. The circuit is shown for single phase semiconverter over here. If we look at the circuit diagram, we happen to know that we have two thyristors T1 and T2 and two diodes which are named as D1 and D2, and in addition to this we have a freewheeling diode DM, an RL load, and on an input side we have a transformer for as an AC source. We have a thyristor and diode in one leg and another thyristor and diode T2 and D2 in another leg. So we will see the operation of this kind of setup, which is known as semiconverter. There are many possible configurations for this semiconverter. In some books they use both the thyristors T1 and T2 in one leg and use the diodes D1 and D2 in one leg, and in some books they eliminate the need of this DM, but in this book MH Rashid that we are following, we are using this type of configuration in which we are using a thyristor and diode in one leg and a freewheeling diode. So we will continue our discussion using this model. During the positive cycle, T1 and D2 will operate. During the positive cycle, T1 and D2 will operate. The path will be completed via this route in the positive half cycle, and during the negative half cycle, T2 and D1 will operate. During the positive cycle, the anode of T1 will be connected to the positive terminal and cathode of D2 will be connected to negative terminal. Here we have the positive in this polarity, where we have positive over here side on this side and negative on this side. The positive terminal will be connected to thyristor over here, and the negative will be connected to D2 over here. So my load will be connected to the source via T1 and D2, but you see that this thyristor T1 will not operate until I fire its gate G. So once I fire this gate, in that case the path will be completed. This thyristor T1 will start to conduct, and the path will be completed, and current will finally start to flow from this load. When the gate of thyristor is triggered at angle alpha, the thyristor will start conducting. As the gate is triggered, the output voltage will start to follow the source voltage. We have seen this point many times in our previous lectures as well. When the thyristor or the diodes are in reverse bias condition, in that case the source voltage will appear across that thyristor or diode, but once they start conducting, in that case the voltage drop across them will be zero, and the voltage will appear at output same as that of the source voltage, and the current will flow from T1 and D2 from duration alpha to pi, when I am considering that I am firing the gate of this thyristor at angle alpha. Similarly, the thyristor T2 will be triggered at alpha plus pi during the negative half cycle. For this symmetry, I am using the same angle alpha to fire in the positive half and the negative half. Otherwise, if there is a need to obtain such an average value or any kind of combination that I need at output, I can vary the alpha in the positive half and in the negative half to obtain corresponding waveform. T2 and D1 will conduct from alpha plus pi to 2 pi. So during negative polarity, T2 and D1 will operate, and via this T2 and D1 my load will be connected to the source, and the current will flow from this RL load. And in this case scenario, we are considering that my load is a huge inductor, so that, and it is in continuous conduction mode. Current is flowing from this RL load throughout the time. During the interval 0 to alpha, that is the time period in which none of the thyristors have been triggered in that, and from alpha plus pi to 2 pi, this is also the time span or the time interval during which none of the thyristor or diodes are conducting. So in that case, that is when none of these thyristor or diode will be in operation. In that case, the freewheeling diode will be in operation, and it will keep the current flowing from the load, and hence I can obtain output current throughout the time period. Now let us see the waveforms of a semi-converter. This is the waveform of my input side. This is the input signal. V is equal to Vm sin omega t. It is sinusoidal source, and this is the output voltage. This is during the time when this is during the interval in which the first thyristor was triggered at alpha angle, and when that thyristor was triggered, in that case the output voltage started to follow the input voltage from that point, and an output voltage waveform like this was obtained. And in order to obtain a symmetrical waveform during both the positive half and the negative half, the same angle delay was introduced in the negative side as well, and it was triggered at pi plus alpha, and the conduction time is from pi plus alpha to 2 pi, and during this time the second thyristor was operating. This is the current from the thyristor T1. We see that the current from this thyristor T1 will be flowing only in the positive half cycle, and similarly the current from IIT2, the second thyristor, will be flowing only during the duration in which T2 is operating, and it is operating from pi plus alpha to 2 pi. Then we move on towards the current waveforms from the diode ID1 and ID2. ID2 was operating with IT1 and ID2 were operating at the same time. Therefore the same current will flow from both these, and the duration will be from alpha to pi. And similarly IT2 and ID1 were operating together. Therefore the same waveform will the same value of the current peak, RMS, and same wave shape will be flowing from both these.